So let's look at another related rates problem. In this problem, I'm told that in the engine, a 7-inch connecting rod is fastened to a crank of radius 3 inches. The crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. Find the velocity of the piston when theta equals pi over 3. And this is the picture I'm given. So the first thing we need to do, again, is identify our given. What rate are we given? We'll look for a rate here. It's told, I see that I was told that crankshaft rotates at a constant rate of 200 revolutions per minute. So that has to do with the angle. So you have to remember that one revolution, one full time around the circle, that corresponds to 2 pi radians. So I've got to convert my rate into the appropriate units. So d theta dt, I have 200 revolutions per minute, but I need to convert this into radians, so I'm going to multiply by 2 pi, and 2 pi radians, that's the same thing as 1 revolution, so that then my units cancel, and I'm left with 400 pi radians per minute. So that is my given rate. So that's going to be my given. D theta dt, and that's constant, so it's 400, that's always 400 pi radians per minute. What am I asked to find here? So we need to go back and look at our question. I'm asked to find the velocity of the piston when theta equals pi over 3. So I need to find dx dt. That'll tell me the velocity of the piston. So I need to find dx dt when theta equals pi over 3. And then the one part we still don't have yet is our equation. So what goes here for our equation? We have a question mark right now. I have a triangle, but I don't have necessarily a right triangle. And so I'm going to have to think about what kind of formula I can use. And the one we're going to use comes from the law of cosines. So the law of cosines, the way this works, it works for any triangle, not just a right triangle, ABC. The law of cosine says the one opposite theta, b squared, equals a squared plus c squared minus 2ac cosine of theta. So we're going to look at our triangle. Our triangle, we're given, and I'll just copy it back down here so we don't have to go back and look. Or maybe we will have to go back and look. Here's theta. This was x. And then 3 and 7 were my two side links. So 3 was here and 7 was here. So now we're going to plug in. We get 7 squared equals 3 squared plus x squared minus 2 times 3 times x times cosine of theta. So I'm getting 49 equals 9 plus x squared minus 6x cosine theta. You can subtract the 9 and get 40 equals x squared minus 6x cosine theta. So that's what's going to go back up here in my list, back up here for the equation. going to go back now and write that equation right here. So it'll be 40 equals x squared minus 6x cosine theta. All right, so now that I have my equation, I can take the derivative of both sides. So if I take the derivative on the left, the derivative you'll get is 0. The derivative of x squared, 2x dx dt using the chain rule. And then the derivative here, you're going to have to use the product rule for this. So minus, what's the derivative of, so copy 6x, the derivative of cosine is a minus sign. The derivative of 6x is 6 cosine theta. So make sure, oh wait, I forgot. We need to use the chain rule. So when I took the derivative of cosine theta, I should have a d theta dt. And when I take the derivative of 6x, you should have minus 6, and you'll have a dx dt. Okay, so let's simplify. Let's distribute our minus sign. It'll be a positive 6x sine theta d theta dt, and a, oh sorry, that should have been a plus back here, and a plus, it'll become a minus now, minus 6 cosine theta dx dt. So what are we trying to solve for? Go back to the beginning of the problem. What did I need to find? Dx dt. So this is what I need to find. So that's what I'm going to solve for in my equation. So I'm going to move this term to the other side. I'm going to subtract it away. I'll get minus 6x sine theta d theta dt equals 2x dx dt minus 6 cosine theta dx dt. Factor out a dx dt on the right hand side, and you'll be left with 2x minus 6 cosine theta. So if I solve for dx dt, you get minus 6x sine theta d theta dt over 2x minus 6 cosine theta. So do I have everything that I need? Well, I know I was given d theta dt, and I know theta, it was pi over 3, but the thing I don't know yet is x. So we're going to have to solve for that. Theta is pi over 3, so go back to your equation, which was 40 equals x squared minus 6x cosine of theta, but now theta is pi over 3, so pi cosine of pi over 3, it's 1/2. So I'm going to get x squared minus 3x, and I'm going to go ahead and subtract the 40 to the other side. And this will factor into x and 8 and 5, a minus 8 and a plus 5. And so you get two answers. X is negative 5 and x is 8, but the negative 5 answer doesn't make sense. So x is 8 inches. So now I know x, so I can go back in here to my formula for dx dt and plug in everything that I know. So let's do that. So dx dt, it's negative 6, x is 8. It was sine, right? Yeah, sine of theta, so sine of pi over 3 divided by 2 times x, so 2 times 8, minus 6 cosine of pi over 3 times d theta dt, which was 400 pi. So we're getting negative 48. Sine of pi over 3, it's the square root of 3 over 2. This is 16 minus 6 times a half. So you get negative, so this, in the numerator, the 2, we'll turn this into a 200 times negative 48, so negative 9600 square root of 3 over 13. And then we need some units, and we need a pi here, pi. We need units, dx over dt. X is in terms of inches, t is in terms of minutes. So my unit here should be inches per minute. And there's my answer for dx dt.